Welcome to Access Lists. This is a lesson on controlling the flow of traffic. But not only that, access lists can be used for other things, but blocking certain type of traffic, allowing other traffic is where access list gets its most power, especially in the Cisco networking environment. So here I've got Packet Tracer open up here, and we're going to simulate what would happen in a real networking environment. I've got two computers on this side connected to a switch. From the switch to the router, it's just a normal straight through cable. We have the router there. From that router, we have to another switch. We've got two web servers. On Packet Tracer, you can actually simulate web server. So what the idea of this lab is that we're going to do here is none of these have any IP configuration, so we'll be doing the IP configurations on all of these devices. So the two PCs, the two web servers, and either side of the router's interface. But what we want to do is that we're going to direct how the packets will flow, or more precisely, we're going to tell the router which packet to block and which packet to allow through. And we're going to start off with standard access lists in this video presentation. So I'm going to start configuring, and you can follow step by step. And basically, we'll start with the router. So we'll click into the router here, Packet Tracer. We'll go into the command line interface, and we're going to select no. Just for those who don't know. Setting up a Cisco router, you never use the system configuration dialog. It's not very good. All right, so I've got the router here. I need to go to configure terminal. Oh, sorry, I forgot my really basic command here, which is enable. So I need to enable this configuration mode now. So I know that there's interface, that's a gig interface 01 there, and that will be a 01 there. So I'll go into interface gig 01. Now, I'm actually not sure why that's not showing it there, but let me just see if I can fix that. So that's interface on that side. I don't know why that's not showing there. Let me just correct that. It's a bit weird. So gig 01 over to, now I know that it's just a little bit of a glitch there. So we're configuring this interface. That will be the gateway for these two computers. So when we go into the gateway, and if we go to desktop and IP configuration, that IP address that we put here will be the gateway address. That's what gateway address means. That's the exit path. That's the way out if we need to direct traffic outside of this local area network. But first, we'll go back to the router. I've done interface gig 01. Let's configure that gateway address. Before I do that, it might be a good idea just to label these configurations. So I'm going to do 192.168.2.1. That's that for that interface there. And the network mask is 255.255.0. Okay, let me just move that aside a bit. Maybe put that there. So that's the gig interface. Actually, I might even just be more specific here. It doesn't hurt to do a little bit of extra documentation. Okay, so now I've got a document of this. I might just copy this. Let's copy that. And do the same on the other side for that interface. Paste. But this time, I'm giving it another IP address. So that will be gig 0, 0. You don't have to do this, by the way. It's just my documentation here, so just to make this a little bit easier for you. And then I'm going to put 1.1 there. So that'll be the IP address for that gateway for that side. That will be the IP address for that interface there, which is the gateway for this side. Okay, now we can go and do it. IP address 192.168.2.1.0, and then I do a no shut. So that will go into an upstate, and that will allow communication with this network. You can press the fast forward button if you don't have any patience. Now we'll configure these computers. Give them IP addresses, 192. Remember, they'll have to be on the same subnet as the two network here. I'll just make it a 10. I like to make it nice and even numbers just to make that a little bit easier as I'm learning and developing my skills. Keep it simple. And gateway is 2.1. That's the gateway. So that computer knows that if it cannot find its where it's trying to send the IP address to, its last resort, saying like, well, I don't know where that the destination is. If I don't know where the destination is, I'll send it to my gateway. The gateway hopefully will know. No need to worry about a DNS server because we don't have anything that uses name services in this particular lab. Okay, so that's good on that side. You know what? I might just put a label there. Just in case. And I'll put one over here. So 2.20, that's the IP address, and I just like to put the network mask. But for you all, I would get into the habit of doing it as the side annotation. Do a quick little bit of research into that, and that just makes it a little bit easier to read. But anyway. You might even want to, if you wanted to, you can write gateway as well. So it means you don't have to jump into the computer all the time to have a look into it, to actually see what the configuration is. It might save you a bit of time, but options, always options plenty. Do it the way that you're comfortable with. Not sure why that went like that. Yeah, it's a bit weird, I don't know. It's not behaving properly today. Okay, well, we'll have to put up with that. Now, I'm going to do the configuration on the computer on that side. Desktop, IP config. It kind of simulates what a Windows device, how you would configure a Windows device. Not exactly, but it's not bad. It's good for simulation. Beautiful. So let's test, let's ping. Now you can select the envelope on the top here, go to PC to the router, and it says successful on the bottom there. I prefer to do it the good old fashioned way. Go into the PC, go into a command prompt that looks like the old DOS command prompts from Windows, or even today they're still there. And I'll do a nice ping. So I'm going to ping from here to that gateway. If I can do that, then that setup is pretty good. 682.1, and there we go. We've got communication happening. So this side is good. So I'm going to do the other side, but just I'll just put some labels here. 192.168.1.10. I'm not going to put anything else because I think you get the drift. Oops. 20. Okay. So it's on a different subnet, different network completely. Let's configure the gateway address for these two servers. There. Okay. I'll end that. We'll do it again. Config. But I'm going to do some shortcuts this time. Config conf t interface gig 00 network 192.168.1 255. This is the network mask. Oops. Sorry, my mind was somewhere else. I was thinking of networks in routing configuration. No, we actually want to do IP address. 192.168.1.1, 255.255.255.0, and now no shut. Beautiful. So it's doing the opposite of a shutdown. If you want to shut down something, you type shut. This is the opposite. Routers come out of the box in shutdown mode. We need to unshut it or no shut. It's a bit of a strange terminology, but that's Cisco. Fast forward it because I don't have any patience. Let's go into these web servers, give them IP addresses, and then we'll test that these web servers can be accessed from either of these computers. A good little lab here actually. It's real world. We'll go into desktop, we'll give it an IP address. That same IP address is there. 192.168.1.10, 255.255.255.0, and the default gateway 192.168.1.1. That's a .1 there, right there. Perfect. We'll go over here and do the same. 192.168.1.20 this time, and the same gateway. If this is going a bit fast, you can put this recording in slow mode. But I think we should be okay now. We're going to check to see if the web servers are available in Packet Tracer. It's not as simple as this in real life, but in Packet Tracer, we can go to services and HTTP, and it's on. We can tell that's on. That's the web pages that we're going to go into. Now, because we don't have a domain name service, we'll access those web servers by its IP address, which is a good segue into DNS, domain name service, if you ever want to look into that. If I know the IP address of a web server, I don't really need to type in a name, but that's also a problem because there's a billion IP addresses out there, so I can't remember all of them. But okay, well, PC2, let's see if we can access both of those web servers. Actually, I might, what I might do is I'm going to change these names around a bit, because that should be PC2 and that should be PC1. And that should be web server 1, web server 2. Okay, that's better. So from PC1, let's go to the web browser. And type in this URL 192.168.1.10. 10, that's the web server. If I click on go, perfect. So we've got the web browser. We've got web browser connected. It says hello world, copyrights, image, Cisco's image there, and oops, another image. Okay, so that's worked. So from there to there, it's working fine. Let's test this one now. Web browser. Might take a little long sometimes. 192.168.1.20. And there we go. We've got the web browser as well. So that computer can connect to both of those web servers. Let's have a look at this computer. So this computer, let's see if we can access both of those web servers. Web browser. On PC2 now. 192.168.1.10. Perfect. And let's see if we can get the web browser 20. .192.168.1.20. Okay, perfect. So we have connectivity. Now I could ping as well. Let's do a quick ping, why not? Let's see if we can ping both servers. So ping 192.168.1.10. Yep, so we've got that. That's good. And let's go to the other one. Excellent. So we got communications on different protocols now. One for one using port 80, which is HTTP traffic for web servers, and now we've got one for ICMP, which is ping. Let's do the same there. It's always good to do this, just to make sure that you have a baseline, and you know you're very satisfied and you're sure that everything's working at the beginning before we add the access list. But we are now ready to configure a standard access list. Now, standard access lists, they're okay for small networks, but they don't give us a lot of options. And this was a solution, we're talking about the 60s and 70s when all these things were being developed. So they were great for the time, but they don't really have that much value here. But it's still good to learn these just to get an idea of how they work. So I'm still in the configuration mode, or global configuration is the technical term for it. I'm going to create an access list, and I'm going to link that access list to the interface. And I will do the same for the two different access lists. So the first access list, the scenario is this. This computer is not permitted to access the web service. Now, because it's a standard access list, it only blocks, or it only denies or allows using the computer's a source IP address. I can only block or deny based on this IP address. There's no other option with standard access list. With extended access list, there's a lot more variation. There's more things we can do there. Destination, source. But with this exercise, I can only block the source destination. So I cannot block this PC from only getting access to that server, or only that one. Unfortunately, that's the limitation of a standard access list. But the first access list we're going to do, block this PC from accessing these web servers. And the second access list we're going to create is block PC2 from allowing it to ping to either one of these servers. Now, the general rule is this. It's not a rule that Cisco, the actual router, will, you can configure any way you like, but Cisco recommends with standard access list, if you've got several routers along the way, add the access list as close as possible to the destination. And that's because standard access lists will get blocked pretty quick. They'll won't work because there are other access lists, they'll block them at the beginning of the journey. So whereas extended access list, put them as close to the source as possible, because you've got so much control. You can specifically control exactly how your network works. So you want to do as close to your network as possible to save traffic. All right, now, so let's go and configure these access lists, shall we? So I'm going to type this access list. At the beginning, I'll write the full commands, and then later on, you'll be seeing me doing shortcuts. So access list, deny 192.168.2.10. I'm sorry, I realized I just made a slight error before in my explanation. We won't be able to we won't be able to block via HTTP or ping. Just click that now. It just occurred to me that with standard access lists, you can either block the traffic or you don't. So so we'll be blocking this traffic from PC1, but allowing PC2. So that'll be the goal of this lesson. So access list 1 deny 192.168.2.10, and then we'll select enter. Then we're going to do access. And there's a shortcut is tab, and that'll fill out the rest of the command there. Then we need to do permit everything else. Otherwise, there's an implicit deny at the end. It means that if I go through the access list and it reaches the end, if there's no permit at the bottom, then it will think that we want to deny everything. And that's what's an implicit deny. We're not explicitly stating that we want to deny all the traffic. We want to allow actually the rest of the traffic so this computer can get through as well. Okay, now we've done that and we've got the configuration. Where are we going to put it? Well, remembering what I said, that the standard access list should be as close as possible to this exiting interface. So let's add it there. So we'll go back into that. We need to go into the interface mode now. Interface gig 00. And now we type, we'll go into this. So we're in the interface now. So then we type access list. Sorry. Access, yeah, no, I'm right. Sorry. Access list 1. Deny host. Sorry. It's a bit challenging remembering these commands. Oh yeah, access. No. It's actually IP access group. IP access group out, because it's going to be out of that. So direction is very important. The source is very important, and the direction and the interface. The interface and where it's going is really important. If I put that in, the packets will be going that way, but will not return back. So it's important to know exactly how you're configuring it. It can be a complicated configuration or a topic to understand, but just remember, when it comes to access list, interface and direction are critical. Which interface is it coming? Is it G01? Is it G00? And is it coming in or is it coming out? So if the traffic is flowing that way, that will be out. If the traffic is flowing that way, then that's in. Really important to try and understand that. But so the traffic's coming from that way, so we're going to go out. That way, right there. Actually, I've just realized that we can set up a way where that we can deny pings, because we can do another access list that comes from that way. I'll show you now. Actually, so we can get that. What I had hoped to set up because I want to block pings from there. It can be done. Watch this. But let's do the HTTP first. The first access list first. Out. I did write out, didn't I? You know what? So access group 1 out. Okay, must have been a typo. Yeah, I've got the 1 because that's the access list. That's the name of it. That's the number of that particular access list. Perfect. Now this should be working, or I mean, it should not be working. We don't want it to work. Remember before we tested if that worked or not? Let's go back to, and it did. Now go back to the web browser and we'll try that again. And we're not getting anything in return. There's nothing coming back. It's trying to get there. It's blocked on the way out. So that's working, but let's see, actually, we might be able to do it the way the ping demonstration, because we're doing it by IP addresses. This could still work. Request time. So that's done its job. We've blocked the traffic going to the HTTP, the web server. Let's do the other one where we're sending traffic from here to there, but via ping. And I want to show you something. You know what? I think we can do this. Ping 192.168.8. 1.10, actually, yeah, 1.10. Yeah, okay, it's working now. Now I'm going to show you a nice little trick. You can do this, and I'm just going to try and remember these commands because there's a lot of them. If I do that, no, sorry, I'm getting my Linux and Windows mixed up, which will happen to you once you become really awesome network administrators. You'll learn Linux and Windows and Cisco, and you'll get the commands confused. But it's number, yeah. That will ping 10 times. Now, I'll show you something else. I'm going to do it 1,000 times now. It'll just go on and on and on, because I'm going to block that IP address from pinging to that web server. When I press enter, we'll see that it will be stopping. So let's do it. And this time we can actually put that on the same interface. Okay, all right, go exit, one level. We'll press the up arrow button again. And I'm going to do this. Deny, I can't stop, I can't configure an access list to stop pings or HTTP like I mentioned before, but I can stop all traffic coming from this direction. Not ideal. I was going to try another way, but I think this still helps us understand that we can block source addresses. We can also block by network as well. If we want the whole network to be blocked, all you do is you write the network address plus the wildcard mask. But that's a topic that you should be researching in your own time, because that's a tough one, a challenging one. Okay, so access list 1, deny 192.168.2.10, and that should get us there. And don't forget the permit ini. Okay, do show access list, just to confirm what our configuration is. Perfect. Oh, by the way, you get to see matches here too. You can see whether on the router whether that it's some have got through and some have not. That's a really good handy confirmation tool. Yeah, do show access list. Okay, do show run. So I want to have a look at my configuration now. I want to double check something, because for some reason I did that, and I'm not really sure why I did that. I need to fix that. That's good to verify. I'm really happy that I verified that, because I made an error, which is okay. We do make errors. So I want to deny. Yeah, look, I realized they can get complicated, these access lists. I realized that I actually can't put that. If I want this to continue to be using the web traffic, I can't actually put a access list there to stop that, because remembering we can't stop ping or HTTP, but we can only stop IP addresses. But I can stop it on the return journey. Watch this. I'm going to block any traffic coming from that, from this one here, from coming back here. Or actually, why don't we do all of it? So this computer will no longer be able to access the web servers or any communication at all. See how rigid and how standard access lists are? We can only do through IP addresses, but you know, it's what happened. It's what we had to work with a long time ago. So I can't put it on the same access list as that one. I'll have to add another one. So I'll need to fix this one first, because I messed that one up. No, actually, no, I didn't. That's fine. 2.10. No, this is fine. This is fine. Let's test it. We'll go back here. Wait till you start learning extended access lists. Then it'll be fun. The fun begins then. Yeah, that's not going to work now. Perfect. So what I want to do now, we'll go back here. Yeah, so I'm going to block the IP traffic from going to this computer here. And so it will get there, but on the return journey, it will not. It will not come back. We'll do that. I think that will be a really good exercise. I am contextualizing live, changing the plan, because I think there's good value in doing it this way. So I'm going to stop it on the in, this time on the gig 0001. So access list to the second one, deny, okay, and I'm going to do 1.1. Then I'll go into the interface, which is gig 00. And this time I will do a IP access group 1, but coming in, okay? Or, you know what? Yeah, let's do that. We'll do it this way. Not recommended, Cisco doesn't recommend me doing this, but because it's close to the source, but let's do it anyway. Because I just want to show you that I've got 2 access lists on the one interface. So .1, and that's in this time. Let's just do a do show run, and I'll show you what we've got here. So you can see that I've got the access list 1 and 2. Ah, look what I forgot to do. I forgot to put permit ini on the access list for 2, and I've got the wrong IP address there as well. Okay? It's always good to verify, always. So I've got to fix this again. Yeah, look at that, see? Happens, you know, you make mistakes, it's all good. Fix it, move on. Yep. Now what I want to do is go up a bit. I want to show you that by going up you can have a look at the previous commands. The up arrow button. I'm going to change that to 2. Now do show IP do show run. Now that's a bit better, but that's still there. We'll need to delete that. I'm going to copy that, and then I'll do a no in front. See where I'm going with this? And let's do a up arrow button, do show run again. And it looks like that I have deleted everything now. I deleted the whole lot. Wait, what? All that hard work? Frustrating. There's access list, standard access list. And I'm sorry for torturing you like this. Just want to show you that standard list is very cumbersome. Okay, now let's get this working. Okay, enough torturing, enough annoying you. Let's get this done. So access list, I'm going to tab. I'm going to do this pretty quickly. Host 192.168.1.10 access list to permit any, and let's do a do show run. There we go. We are now fully operational. This is going to work now. So I will be able to ping this computer, but I will not be able to ping that one. Okay, let's try it. We'll send the envelope over that way. Successful. Send it this way. Oh, it's still successful. I wonder why. It should be blocked from that side. So let's see if it's okay. That's interesting. So I've done deny host. But what about the direction? I forgot to put the direction of it coming in on the interface. Okay. Now that time that was not intentional. I just simply forgot. Interface gig 00, and now we have to do IP access group 2 coming in now. So remember, look at this. Remember we did this? It's still running. I'm just going to put this here for a bit. I'm going to put this side to side So now that I've got this, look at that. It's timed out. See that? I know it's working. I'm going to show you something. If I negate that, if I do no IP access group to in, it should shortly come work again. This is a great troubleshooting tool, using ping while doing it 1,000 times. Now, if I put that command again, it'll block it. Request timed out. Okay, perfect, so it works. Now, can I still communicate with this computer to this server? Well, let's try. So I'm going to press Control C to escape this. Let's ping the other server now, and I still can. So you can find ways to make this work. You can get it to work, but it's tricky, and it requires being really clever and having the design really well. Extended access lists are far more powerful. I can block by protocols, and I can both directions from the source and destination, all this kind of stuff. It's complicated though, but very powerful. Well, I'd like to thank you for watching. Thank you, and hope to see you soon in the future.